You're on.
Hey guys, we're here with Mr. Z and Mr. B, and we've got our students.
Jasmine, Anursha, Shiza.
And we're going to start talking about some of these definitions to help us with this flowchart to identify the texture of these rock specimens that we're looking at.
So it would be a really good idea if you opened up your packet to page 23, and we have the flow chart up on top, and then we have the definitions of the igneous rock textures that we're going to cover in the video. So pen ready in hand and pack it out. All right, let's get started, Mr. B.
All right, so the first one that we looked at was fragmental. Okay, what do you guys think of when you hear the word fragmental?
Fragment.
Yeah, fragment, right? Well, what's a fragment?
Like little pieces.
A bunch of little pieces, right? Okay, so when we think about little pieces, we're thinking about during or following an eruption, we have a bunch of other little pieces that are fused together. Okay, so let's say you've got a bunch of rocks that are on the side of a mountain or the side of a volcano, have an eruption, and then the lava that comes out fuses all those pieces together. Okay, that's what we call a fragmental rock. It's just materials fused together during or following an eruption. Okay, if you guys want to see an example of it, we've got an example. It's this kind of white-looking one with bigger rocks found inside of it. Okay, so if you see it, we've got different sizes of it put together. Okay, so we've got fragments of other rocks that are all fused together. Make sense? Okay. Mr. Z, you want to take the next one?
Of course. The next one we're going to talk about is something that is glassy. All right, and in the other video, this was identified as this one. All right. If you wouldn't mind actually picking up one of these, some of the other examples that are over there, right? So if we were taking a look at this, right, do we see any crystals in here?
No. No.
No, right? And actually, if you feel it, it actually feels like glass, just like a glass jar or a cup or anything like that. It feels like that. And this one doesn't really have any crystals. It doesn't have any crystals that can be seen or that actually formed. And the environment for producing this texture is lava itself that is instantly cooled. So it's quenched by either air or water. And that rate of cooling being as fast as it is, it doesn't allow for the atoms and molecules to kind of arrange themselves into an actual crystal. All right, and we're going to be talking a lot about the rate of cooling and how that affects or determines crystal size, okay, in these other textures. But for this one, this rock cools the fastest and does not give us any crystals at all. The atoms cannot arrange themselves, and that gives us this glassy texture.
Now, do you guys see any other ones on here that look like they cooled really quick and there isn't any time for crystals to grow? So you're looking for something without crystals. Okay, well, let's see on this one. We see some little fragments in there, some little crystals in there. Thinking of that one that we picked up last time that was really, it wasn't very dense. Yeah, this one that wasn't very dense, and it cooled so quick that it didn't have time to grow the crystals. But what's different between this one with the little, I almost gave it away, the lighter one, and the really dark glassy one too?
That one's like shiny.
This one's shiny, yeah.
And that one's like dull and like rough.
This one's kind of dull and rough, okay? Which one do you think had more bubbles in it when it was cooling?
The lighter one?
Yeah, the lighter one, okay? So that's the only difference between these glassy ones, is that the dark glassy one, that's shiny, didn't have bubbles in it, and the lighter glassy one had bubbles in it. Make sense? Cool. Alright, next one we got is pyroclastic. Okay? There's one word in there. What do you guys recognize that first part of the word pyro? Have you ever heard of that before? What's pyro? What do you think of that?
Yes. I've heard that, I don't remember.
Okay, do you have any friends that like to play with fire? The kids you kind of stay away from in grade school.
Probably not good friends there.
Yeah, okay. So what they call them is pyromaniacs, okay? People who really like fire. Okay, so a pyroclastic, it's just something that was ejected from the fire. Okay, so what they call that is usually the ash that comes out of a volcano, and it's usually any material that comes out of a volcano is pyroclastic. Okay? So a lot of this stuff is things that came out of the volcano. So sometimes our fragmented pieces, these are sometimes pyroclasts, okay? Things that came out of the volcano, such as the ash. Okay?
All right, let's talk about the next one here, which is phaneritic. And this was mentioned in the first video, but we're going to review that again. Phaneritic itself is, let's take a look at this guy. Let's pick this one up. If you wouldn't mind picking up, this one, I don't want to say what it is. All right, so what can you tell me about these crystals?
They're different sizes.
Are they different?
Oh wait, no, they're different. Yeah, they're different.
Yeah, some of them are a little bit bigger, a little bit smaller.
Can you guys see the crystals?
Yeah.
Yeah. Do you need a microscope to see them?
No.
Yeah, so we can see them with the unaided eye. Okay? So phaneritic, that's exactly what that means. If the crystals are large enough to be seen with the unaided eye, we don't need a microscope to see them. So if we talked about this one as not having any time to produce crystals, what can you tell me about this rock?
It took a while to cool down.
Yeah, it did, right? Exactly. So the rate of cooling was slower for this rock that allowed the crystals to grow. All right.
Now, do you guys think that it formed maybe really close to the surface? Or do you think it formed really deep underneath the ground? If it took a really long time to cool.
I think deep,
Why do you say that?
because if it was closer to like the surface, then we're gonna have more time to sort of cool off rather than being buried underneath things.
Well, it'd have less time to cool. Or
Oh, that's
less
right.
time. Yeah, it would cool really quick, right?
Mhm.
Okay, if it's underground, it's nice and insulated. There's not a big temperature difference. So it's going to take a long time to cool. So you end up getting crystals that grow bigger and bigger and bigger. Okay, so let's look at the next one. Okay, we've got aphanitic. Okay, it looks a lot similar, really similar to phaneritic. Now, aphanitic is going to mean something where it's crystals that grow, but you can't see them with the naked eye. You have to actually use a microscope. Okay, so let's look at this white one that was kind of fragmented before. Okay, now do you guys really see crystals?
No.
Now, do you see a little bit more than what you would have seen if you had... Oh, do you guys have the right one?
Oh.
Yeah, the pink one here. That was the one I grabbed here, guys. I think I grabbed that one for you. Okay. So, do you guys see many crystals in there easily?
No, but you do see some.
You kind of see something in there, but you're not really quite sure what it is. Okay? Now, if we looked under a microscope, we would definitely see some crystals in here.
So what do you think the rate of cooling for this rock is compared to this rock?
That one cooled a lot faster than that
It did,
one
right? And we can tell that because the crystals are smaller, we need that microscope to see them. So do you think this one is deeper in the earth than this one? No, right? Where do you think this one is?
Closer to the surface.
Yeah, closer to the surface, exactly. And we can tell that by the crystal size. So again, the rate of cooling is determining crystal size. The faster the rate, the smaller the crystal size. All right? The slower the rate, the bigger the crystal size.
Okay? So, we used another term before that we called porphyritic. Okay? Now, here's a big example of a porphyritic rock. Okay? What do you guys notice about this one?
It's like two different colors.
Two different colors, okay? Now, which of the crystals do you think are bigger, the white or the green?
White.
Yeah, the white are much bigger. And can you really see the green crystals at all? No, they're actually pretty small. You'd have to look at them with a microscope. Okay, so what we call this is we've got a rock with two types of crystals. We've got big crystals and really, really small crystals. So we call that being porphyritic. Okay, just when a rock has two crystal sizes. I got a question for you guys. How do you think this formed? Because we have small crystals and big crystals.
Like some of it was exposed and the other half wasn't.
Nice,
great
that's
job.
huge. Which one do you think was formed first?
This side?
The bigger part or the smaller part?
Oh, the bigger part?
Yeah, so what happens is the bigger crystals, they start to form really deep, okay? And then something happens that it gets moved up to the surface really fast. And then we end up forming all these green crystals, okay? So that's a porphyritic rock. When you have two different crystal sizes, it's caused from moving environments, going from a deep surface, deep depth under earth up towards the surface. That was awesome. You guys are so smart. You guys should be teaching this class, not us.
We can also use this example to go to ground mass. because we kind of skipped that one.
Oh,
But
yeah.
if we take a look back at this one, right, and this was mentioned in the previous video. So we have those two crystal sizes, and we already identified that the white crystals are the large ones. And what do we call those again? We have that name for them.
The
Do you
big
remember?
crystals you can
Big
see without a
crystals.
microscope.
Brown.
And, yeah, Fragmental
Wasn't the ground mass?
Oh.
Crystal?
Those are the phenocryst. Great job. So those are the phenocryst because we can identify those, right, with the naked eye. But all these other ones, right, all those green ones, we're going to call that the ground mass. So those are kind of like the background, all right, almost, okay? And those are usually, well, they can be smaller or bigger, and we'll get to that in just a second.
Okay, so if we look at the last two, we're down to two more. We got porphyritic, aphanitic. Okay, so now we're combining some terms we had. So what did porphyritic mean?
Then
There's
that's
two.
like two different.
Two different sizes, okay? And now we're going to combine two different sizes with aphanitic. Okay, so what did aphanitic mean? Could you see the crystals or could you not see them?
You couldn't hear?
You couldn't see them. So if you have a porphyritic rock, you've got one with two different crystal sizes, one with a larger size as your phenocryst, and the other, the ground mass, is something so small you can't see it with the naked eye. Okay?
All right, do we think we could find one of those? So porphyritic, aphanitic, two crystal sizes, one you can identify with the naked eye, and the ground mass you cannot.
Is it this one?
Yeah.
I would absolutely agree with that.
Yeah, exactly. So you can see that there are two crystal sizes there, right? We can see the larger ones. What color are those?
Black?
Yeah, they're black, right? And then the ground mass is what color?
Gray?
Yeah, like a grayish green color,
Mhm.
right? And those we can't identify with the naked eye. So we're going to call that one porphyritic because we have two different crystal sizes, and the ground mass is aphanitic because we can't see the crystals unless we had a microscope.
Okay, and we got one more. Hopefully you guys should be able to figure this one out. We have porphyritic, phaneritic. Okay, so again, what did porphyritic mean?
Two different kind of crystals.
Mhm.
Two different crystal sizes. And what did phaneritic mean then?
You could see them.
You could see them with the naked eye. Okay, so we got to find one of our samples that has two different crystal sizes, and the ground mass is something we can see with the naked eye.
It's like this one.
Absolutely. Describe what you got.
It's like, it has a bunch of different kind of fragments that you can see.
Okay, so yeah, you can see a bunch of different sizes. You can see the pink ones here are pretty large. Okay, and did those form really deep or really shallow?
Really shallow.
Remember,
No,
they
no,
had
really
time to
deep.
grow. Yeah, really deep. Okay, and then the background, your ground mass, is still pretty large. It's large enough to see with the naked eye. Okay, so that's porphyritic because it's got two sizes, and phaneritic because you can see the ground mass with the naked eye. Sound good? You guys are ready to tackle some of this stuff too. Okay.
All right. Any questions or anything that may seem confusing?
So, if it's on the surface, it's going to have less time to grow crystals. And
Mhm.
if it's in the earth, it'll have more time, so it'll grow faster.
Absolutely, yeah.
Exactly, because the Earth itself is a really good insulator. Like rocks themselves hold heat real well. So the closer or the deeper it is, the slower that rate of cooling is going to be, allowing the crystals to grow.
Mm-hmm. So if you're looking for some really big crystals, you got to find something that formed really, really deep.
Okay.
All right, great question.
That's it. I think that's a wonderful job here, guys. Other than that, we're going to start talking about the minerals that we see inside the rocks next, okay? So thank you guys for coming to watch. We'll see you guys later.
Thank you very much.
Bye.